Welcome back, students. So this is part 3 of the chapter Chemical Bonding and Molecular Structure for class 11. In this part we are going to see about Lewis dot structure. So in the last part we have started with the Coastal-Lewis approach. So what was the basis of Coastal-Lewis approach? It was the octet. So every atom tried to attain octet by forming bond. So in the last part we have seen how a single covalent bond is formed, how a double covalent bond is formed, and how a triple bond is formed. So in this part we are going to see to represent how Lewis tried to represent structure of molecule or molecules by using dot structure. So to begin with, let us try to differentiate between bond pair and a lone pair of electrons. So let us take an example here. So here is a molecule which we already saw in the last part. So this is oxygen molecule. So oxygen molecule, we have seen that each oxygen atom has 6 electrons. Each oxygen atom has 6 electrons. So in order to attain the octet, both oxygen atoms decides to share 2 pair of electrons. So if you are looking into this oxygen now, it has 2, 4, 6, 8 electrons. And for this oxygen atom, it has 2, 4, 6, 8 electrons. So that means by sharing the electrons, by pairing the electrons, oxygen were able to complete its octet, and hence oxygen forms double bond, and in that way oxygen attain its stability. So this is what Lewis and Coastal was suggesting. Okay, so in a molecule, pair of valence electron that forms a bond is called bond pair. So if you're looking into this molecule here, you can see 2 dashes, 2 lines. Each line represents a pair of electron. And if that pair of electron is being shared by 2 atoms, so this pair of there are 2 pair of electrons here. If it is being shared by the atoms, then it is called bond pair. Why it is called bond pair? Because this pair is responsible for the bonding between these 2 atoms. So hence it is called bond pair. In short, we call it as BP. So what is bond pair? It is the pair of electron that forms bond between the atoms in a molecule. So that is called bond pair. So you can see from this molecule, there are still some pair that is not taking part in the bonding. So you can see for one oxygen atom, there are 2 pair of electrons that is not taking part in the bonding. So that pair is called lone pair. So pair of electrons, valence electrons, not all electrons but valence electrons that does not take part in the bonding is called lone pair of electrons. So which means that in a Lewis structure, while we represent a molecule using a Lewis dot structure, we will have 2 types of valence electrons. One type of valence electrons take part in bonding. So that pair is called bond pair, and the other type of valence electron, as you can see here, that does not take part in bonding, they are called lone pair. Lone pair means this pair entirely belongs to this atom. These 2 pairs entirely belongs to this oxygen atom. Similarly, these 2 pair belongs to this oxygen atom, whereas these 2 pairs is being shared by oxygen atoms on both sides, which means that this is of both. This belongs to both. Clear? So that is a bond pair, the difference between bond pair and lone pair. In oxygen molecule, each oxygen atom, so if you are taking the number of bond pair and lone pair, each oxygen atom has 2 bond pair. So it has, so for this oxygen it has 2 bond pair and also 2 lone pair. Similarly for this oxygen too, it has 2 bond pair, 2 bond pair and 2 lone pair. Clear? So by using Lewis dot structure. So this is called Lewis dot structure. If you have a Lewis dot structure, you can clearly see how many bond pair is there and how many lone pair is there for each atom in a molecule. Clear? So that's the advantage of Lewis dot structure of a molecule. Now let's look into the compounds with a covalent single bond. We have seen chlorine as an example. Now here we are going to see compounds. So for example, in the case of oxygen, as we have already seen, each oxygen has 6 electrons. This oxygen has 6 electrons. So in order to attain stability, he requires 2 more electrons. So he attains that stability by sharing electron with hydrogen. So hydrogen has just 1 electron. This hydrogen decides to share electron with oxygen. Similarly, this hydrogen also decides to share the electron with this oxygen. Thus, now oxygen has 8 electrons. On the other hand, hydrogen had only 1 electron. So by sharing, he has got 2 electrons. So hydrogen and helium are exemptions. Why are they exemptions? They require only 2 electrons. Why is it so? Because in hydrogen, valence shell is, so I will write it, it has its valence electron is in 1s orbital. And in this valence shell, it has only this orbital, this 1s orbital, which means that if he is getting 2 electrons, hydrogen and helium both are having, so helium already has 2 electrons, and for hydrogen, if he is receiving 1 electron, it has a completely filled valence shell. So here, since it is 2 that is required for hydrogen for a completely filled valence shell, we call it as doublet, not octet. In the case of hydrogen and helium, we call it as doublet. Clear? So whenever there is a stability that is attained due to 2 electrons in the first shell, we call it as doublet. Okay, here in this slide, for higher atoms, for heavier atoms, it is the octet, and for very lighter atoms like hydrogen and helium, it is the doublet that shows the stability. So in the case of hydrogen and helium, 2 electrons will give them completely filled stability, as they have only s orbital. This is called doublet stability. Not only hydrogen and helium, for in the case of lithium and beryllium, beryllium boron, all those will give away their electron to get this doublet stability. Clear? So this is what we have to see. So again, coming back to bond pair and lone pair. Here hydrogen has only bond pair. Both hydrogen has only bond pair. Whereas in the case of oxygen, it has 2 bond pair and 2 lone pair. Now looking into the molecule CCl4. We have here carbon tetrachloride. This molecule is called carbon tetrachloride, CCl4. Now in the case of carbon, we know it has only 4 valence electrons. It belongs to the 14th group. So how to calculate the valence electron in the 14th group? To get the number of valence electron, we have the formula group number minus 10, which is equal to 4. So this is how to get the number of valence electrons. So carbon has 4. So if he want to get that octet, he should get 8 electrons. He should get 4 electrons. He has 4 and he must get 4 electrons. So from 4 sides, chlorine decides to give 1 electron each. So this chlorine, by giving, he will take 1 electron, then thereby sharing. So chlorine has now octet. Again, another chlorine has now octet. This chlorine has octet, and this chlorine also has octet. By doing so, now carbon has 8 electrons. Thus, all the atoms in this molecule is completely satisfied with octet or are stable due to that octet. Clear? So if we're looking into lone pair and bond pair, carbon has 4 bond pair but no lone pair, whereas chlorine, each chlorine has 1 bond pair and 3 lone pair. Clear? Now next, compounds with single and double bonds. So covalent, the compounds that is having both single and double bonds. For example, ethene. You might have learned this in your lower classes. What is ethene? Ethene is C2H4. That means, so I will write it. You might have learned it like this: CH2 double bond CH2. CH2 double bond CH2. So which can be represented like this. So you can see carbon and carbon is sharing two pair of electrons. So now each carbon is having 4 electrons that is shared between them, and in order to satisfy the remaining pair, he will share a pair with 2 hydrogen atoms. So this one is shared with this hydrogen and this one is shared. So now this carbon has 8 electrons. Similarly, this carbon also does the same. Thus he to have 8 electrons, that means octet. Clear? And in the case of hydrogen, it has doublet. So this is how the double bond is formed. Another example is carbon dioxide, in which carbon is in the center and oxygen on both sides. So oxygen will share 2 pair of electrons. Each oxygen will pair with 2 pair of electrons with the central carbon. So that means carbon will have double bond with no lone pair, whereas oxygen will have 2 bond pair with 2 lone pair each. So that's how the double bond compounds are formed. Moving on to the next, covalent single and triple bonds. So into the compounds that have both single and triple bonds. For example, ethane. So this is the same hydrocarbon you might have learned in your lower classes. So you might have learned like this: CH triple bond CH. Ethene or C2H2. Ethane. So we call it as ethane. Okay, so this compound in this carbon and carbon are sharing 3 pair of electrons between them, which makes 6, and the remaining pair will be shared with hydrogen. Clear? So in that way, carbon has attained its octet and hydrogen has attained its doublet. Clear? So while presenting a molecule in this way, every bond pair and lone pair of electrons are represented. So we are making sure that every bond pair, here there is only bond pair, whereas if there is oxygen, you might have observed that there is lone pair also for chlorine. So all those lone pair are also represented. Why? This will make sure that molecule or every atom in that molecule has attained octet. So if you are representing all the bond pair and lone pair, this will make sure that octet is attained for each atom. This type of representation is called Lewis dot structure. So whenever you are representing a molecule, every atoms must have all the bond pair and lone pair around it. This is called Lewis dot structure or Lewis dot method of presenting a molecule. Why do we need that? Because this will make sure that the octet is there, and according to Lewis, Kossel and Lewis, octet is the basis of stability. So in that way you can show that it is due to the octet the molecule is attaining this stability. Clear? So in the next part we will see how to draw these structures. So we have seen how the structures are drawn. In the next part we will see various steps that we should be careful or we should take care of in order to draw this structure. How can we draw this structure? Clear? So that we will see in the next part. Thank you.